So here we have a word problem that uses linear inequalities. It says Hassan is an artist who specializes in geometric designs. He's getting paintings ready for a street fair next month. Hassan paints both pastels and watercolors. So pastels and watercolors is the two variables because we don't know how many he's going to make. Each type of painting takes him about the same amount of time to paint. He thinks he has time to make a total of at most 16 pictures. So this is our first constraint, time. At most 16 pictures. So we're going to do less than or equal to 16. The materials is our second constraint. The materials for each of the pastel pictures will cost $5, and the materials for each watercolor will cost $15. He has at most $180 to spend. So that's our second constraint. So I'm going to highlight that. And that says at most 180. All right, so now we need to record these two inequalities. So first the time, and we're going to use P for pastels and W for the watercolors. So when we add these two together, we cannot be more than 16. So that's our first constraint, is to write P plus W is less than or equal to 16. When we add the two paintings together, we got to be 16 or less. Now the cost, that's where the 180 constraint is. So for here, so I've got $5 for every pastel, so $5 every pastel. And then we have $15 for every watercolor. And we need this all to be less than 180. Okay. So now we're going to graph these two constraints on here, and the shaded region is going to be the feasible area. So when we have our variables on the same side, we want to use that trick where we find the two intercepts. So we're going to do that for both. So if I put 0 in for P, then 0 plus 16 is 16. So this is going to have to be a 16. And same with this one. If I put 0 in for W, 16 plus 0 is 16. So I'm going to put that there. All right. For this one, if I put 0 in for P, then this is gone. So it's a positive 15. 180 divided by 15 is 12. So if you didn't know that number, you just type in your calculator 180 divided by 15. We'll tell you that number. This one here, if we put 0 in for W, then that's gone. And we have 180 divided by 5, which is 36. So 180 divided by 5 is 36. Now I can plot all these points on here, but I want to make sure that I have a scale that will accommodate all this. So I'm going to have to go by twos on this. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 2, 4, 6, 8, 30, and 2, 4, 6, 8, 10, 2, 4, 6, 8, 20. Okay, let's plot all these points. 0, 16, 16, 0. It can equal, so it's going to be a solid line. If I plug in 0, 0 as a tester, so this point 0, 0, 0, this will become 0. 0 is less than or equal to 16 is a true statement. So this is going to shade towards 0, 0. Okay, and the next one, I'm going to plug in those two. So 0, 12 and 36, 0. And connect those. And again, if I plug in 0, 0, this whole side becomes 0, and 0 is less than 180, so that's also true towards 0, 0. So I'm going to shade where everything is true. So everything's pointing to this region here. So that's where I'm going to shade. So this is my feasible region. That is where Hassan can make any of his paintings in this region. So you can make 8 of these and 0 of the other one, or 8 and 2, 8 and 4, 8 and 6, and so on and so forth. But anything out here is not feasible based on these 2 constraints.